Everyone, so today we will be starting over chapter number one of ITech 3100 networking class. And chapter number one is about introduction to networks. We will be discussing the fundamentals of network. We will discuss the core concept of networking. We will discuss the different models of network, different types of network, and some basic functionalities of computer. So I have divided this chapter into two parts, and today we will be discussing part one of chapter number one. So in the first part, today we will be talking about these two agenda items. We will discuss the basic definition of a computer, its different components of computer, and different functionalities of computer. Then we will discuss the network communication model. We will discuss that in order to design a network, what sort of components like hardware and software that we need, and how we can design a network. And in the part one, we will continue our discussion. We will discuss different layers of network, and we will also talk about certain network models as well. So let's start with the definition of the network. So, network, if you define a network, what exactly a network is. So, the technical definition of a network is the group of computers connected together. So, computers, group of computers, or you can say collection of computers, group of computers connected together. So, a group of computers connected together using transmission media. So this transmission media can be a wired one, or it could be based on wireless as well, transmission media. Now the next question is why typically we design a network. Okay, why we need to, for example, I have this computer, this computer, this computer. Why do we need to connect all these computers? What's the purpose? The purpose, there are two main reasons why people design a network. The first reason why do we design a network is so computers can exchange information. It would be easy to exchange information if they are connected together. Second is so they can share resources. So these are the two main reasons why we design a network. Now, very importantly, the most important component, or you can simply say the object of digital world, is computer. So a computer can be in any form. Like, it's not mandatory that computer should be in the form of like a monitor, keyboard, and all that kind of stuff. A computer could be, let's say, a server. So there could be many forms of computer could be a server, or computer could be maybe, for example, your smartwatch. For example, a computer could be personal computer, it could be iPad, it could be etc. etc. All even, for example, your car push start button. That's basically a system on chip. So all these are different form of computer. Okay, and for example, if all those computers are connected together, that's basically a network. Okay, so to understand the network concept in detail, let's understand a definition of computer, and we will discuss the basic components of computer. That will kind of make more sense. Okay, so let's move on to the definition of a computer. So what a computer is. So if you want to define a computer is any component which can do three things. Like, for example, we have, this is form of computer. So any device, any computing device which can accept input, like you can give an input, which can, for example, process your input, can do the processing, which can, for example, give you an output as well, like understandable output, which human can understand, or for example, can be further utilized. So any device, any computational device which can do input, which can take input, which can process the input, or for example, execute the instructions and can give you output, is called a computer. Now, there is a possibility like a computer just accept input and it basically doesn't give you output. There's a possibility, but most of the computers they perform all these three functions. But it's not mandatory that computers they have to perform all these three functions. The next is the how we can give an input to computer, how we can interact with a computer, how we can give an input to computer. So for example, let's say this is a computer, and you want to, for example, talk to a computer. So just imagine computer is basically a person, and you want to talk to a computer. Let's say this is you, and you want to, for example, type A, B, C, or whatever the keyword to your computer, and you want the computer to understand it. No, computer cannot understand human language. So this is over human language, and computer cannot understand human language. If you want computer to understand what you want, because computer can get things done for you. If you want computer to do something for you, you need to convert this human language into a language which is called machine language, so machine can understand. And machine language also known as binary, like 0101 and those kind of things. So how we can do that? In order to do that, we use input devices. So input devices, what they do is allow user to interact with computers. So users can interact with computers, user can give input to computer, or for example, in simple word, these input devices, they convert human language into machine language. Now, examples of input devices, let's say you want to send input to computer, so you can use, for example, keyboard. Keyboard is one of the example. Another example, for example, stylus, the pens, are all these things. For example, microphone is another example. Sometime, for example, if you're taking a data or reading a data from storage device and processing it, you can do that. For example, take the data from hard drive, process it, and give it to a monitor, or for example, maybe send it or store it to another device. Storage devices are also sometimes treated as input devices. So if you want to talk to computer, we use typically input devices. Next is the processing. And in a computer, most of the computers, they do have a CPU, and CPU stand for central processing unit. Central processing unit. Now, this is called a brain of computer, because whatever you want to execute or get done, it can be completed, or it can be you can get it done through the CPU. So CPU is basically the brain of computer. And what exactly it does, for example, if you want to execute an instruction, let's say, for example, you want to run a software, you want to run an application, software, or anything like that. So application is nothing, or software is nothing but set of instructions. So for example, if you want to execute an application which is set of instructions, like how to run it, so how to, for example, use that particular software, you can get it done through the CPU. So CPU, what it does, CPU executes the instructions, to run a software or to run an application. So typically what happens, if you have one CPU, it has two main parts. One is called control unit, second is called ALU, arithmetic logic unit. So for example, if on one chip you have two control unit and two ALU, it's called multi-core processor. Just like, for example, a person having two brains, for example. That's what we have discussed. So first of all, a computer should be able to give you input, like users can interact with computer. Secondly, it should have a mechanism to process the user input. For example, compile the data into information, make it more meaningful, execute it, run it. And the last one is output. Output is something which is like, for example, let's say, in simple words, if you want to understand it, output devices basically converts machine language back into human language. So human can understand it. For example, let's say this is example is monitor. So whatever is running inside the computer, it is 1010. But whenever computer wants to communicate, it's going to be, for example, maybe a sound, maybe, for example, a graphic, or maybe a text or something like that. So this is basically what computer can communicate, and that's the sort of output computer should generate so human can understand. So examples of output devices could be, for example, your monitor is the example, your speaker is another example, etc, etc. Even scanner, and even as I mentioned earlier, the storage devices are also the example. So what we have discussed the definition of a computer, what a computer is, why do we need a computer. We have discussed in a network, the object of a network is basically a computer, and computer could be a router, switch, computer could be any computational device which is able to perform these three things: input, processing, and the output as well. Beside input, output, processing, computers typically they also have a capability to store the data. They can store the data, and storage devices also play a very important role in a computer. They define the capability of a computer as well. So typically the storage devices can be of two types. Storage device can be a short-term storage, short-term, or it could be a long-term storage device, long-term as well. Short-term and long-term are basically based on based on their capability, for how long they can hold the data. For example, let's say if we talk about short-term storage, so short-term storage devices are basically those devices which holds the data temporarily. Okay, so they typically are volatile means requires constant power supply to retain the content, requires constant power supply to retain the content, to retain contents. So for example, if you turn off the power supply, the data will be lost. The example of short-term storage device is RAM. The best example. There are many other examples like cache, registers, etc. RAM stand for random access memory. I'm sure everybody heard of that. Random access memory. Every computer got a RAM, and RAM is very important component. Why? Because this is the most active part of your computer, active component, active part of the computer, also called working storage. It's also called working storage. Why we call it working storage? The reason is, whatever you see on your computer screen, it is basically on the computer. Let's say this is your computer, and whatever is running, even for example, you are watching a video. So at a time you watch a picture with the audio part. So whatever comes on your screen, it is basically stored onto the RAM. So it holds the currently in use data or information. So whatever you see on your computer screen, it is basically stored onto the RAM. Okay, and for example, whatever you can run, because RAM is very important component of your device, of your computer, because let's say if RAM is small, you cannot run the large program. So if you have larger RAM, you can run long programs. For example, you can run, for example, the heavy programs, or you can say applications. And there is a possibility, for example, your RAM is not enough to run a program. And let's say you got a 1 GB RAM and you wanna, for example, run an application requires 2 GB of RAM. Still you can run it, but it's gonna be slightly slow. So if RAM is not enough to run or support a program, then it uses secondary storage, disk drive, secondary storage. And what is secondary storage? Secondary storage is hard drive, HD hard drive, secondary storage as a supplement. But please remember one thing, use this particular idea or technique is not that great. The reason is RAM is very fast. Like RAM, this RAM is very fast. It is very fast, volatile, and hard drive is not basically, the speed of hard drive is not close to RAM, because hard drive is larger and larger space is a little bit slow as compared to the RAM. Okay, now let's talk about the long-term storage devices. The long-term storage devices are basically those devices which can retain the content even if you turn off the power supply. So these are basically long-term storage devices are called non-volatile. Sorry about that. It's called let me clean this. All right. So it's called non-volatile devices. Non-volatile mean, for example, if you turn off the power supply, still they will retain the content. So retain contents even if you cut off the power supply. So the example of non-volatile devices or long-term storage devices are, for example, your traditional hard drive, hard drive HT. I'm using HT term for hard drive. Let me write it down here. Hard drive. For example, SSD, solid state disk drive, in fact, solid state drive. Okay. For example, CDs, compact discs, for example, DVDs, for example, USBs, etc. So these are basically called long-term devices because they retain the content even if you cut down the power supply. The traditional hard drive, maybe you have seen the traditional hard drive. It's look like something like that. You got a platter and there's basically a read-write head onto it. And it basically use magnetic field to write and read the data. So to read and write the data, it uses basically the magnetic induction. Okay, so magnetic field is generated and it can read and write data, but there is basically a movable read-write head, and this is basically, the disk is called a platter. It's magnetic basically platter. So there's a movable head which moves on it. For example, if you want to read a specific type of data, it basically moves along on that particular platter to scan the data. While SSD, the solid state drive, it mainly uses flash memory. So flash memory is basically where we store the data in the form of registers. So we store the data in the form of registers, blocks. So it's like something like that. So your data is basically stored on these particular blocks. So no movable read-write head, no read or write heads, no read-write heads, no moving part. And these SSDs are basically becoming very common nowadays, and SSDs are faster as compared to traditional hard drive. Other than that, these are expensive as well, and typically these SSDs, they come with mobile phone where we have, for example, very abrupt sort of mobility. For example, tablets, etc. Some handheld devices, these SSD is more common as compared to the traditional hard drive. Retain the content even if you turn off the power supply. In these devices, for example, even if you use hard drive or you use SSD, we store the data in the form of bits, like 1010 form of bits. So the data is basically processed, or data is basically stored in the form of bits. And the bit value can be 0 or it can be 1. 0 or 1 can be the value of the bit. 0 mean, for example, if I have a data, let's say A, and you want to store A onto your hard drive. This is not basically the form if A will be stored. You use the input device, let's say keyboard. So they typically use ASCII codes and things like that, convert A into 0101 or something, and then it will be stored on your hard drive. So bit 0, how do we store bit 0? It is basically absence of power supply, power, or you can say voltage, absence of voltage, while 1 is basically presence of 5 volt. Typically it's basically we use 5 volt to store a bit. And again, let's say if it would be fiber optic, it could be absence of light. And for example, if you want to store 1, so it is basically the presence of light. Okay. Normally the data processing are in the SSD or flash drive, we process the data in the form of bytes. So byte is basically the unit that we use for storage, and 1 byte equal to 8 bits. So like something like that, 0101 0001. So this is basically 1 byte. Okay, so because if you start processing the data or storing the data in the form of bytes, units, it's going to be very hard to in order to compile it, in order to organize it. It's going to be very hard to understand. The other hierarchies for the disk, for hard drives, we use different methodology. Let's say byte is the smallest one for hard drives. The next is kilo. And the K is basically the abbreviation. Let's say KB, it is basically 10 raised to power 3, like 1000. The next to K, let's say 1 KB mean 1000 bytes. So let's say 1 KB mean 1000 bytes if you have 1 KB of storage. Let's say if you have 1 MB, MB is basically megabyte, mega. And it's represented as M. B is for the byte. It is basically 1000 kilobytes. Okay, so 10 raised to power 6, close to million as well, but since it's a digital system, so you can never get basically 1000 or 10,000. Next is giga represented as G, and it is basically 10 raised to power 9. And if you convert it right here, so 1 GB is equal to 1000 MB. Okay, similarly, for example, next is the tera, and T 10 raised to power 12, and 1 TB is equal to 1000 GB. Okay, similarly, for example, next to tera we got peta. Peta is P 10 raised to power 15, and again the same way 1 PB equal to 1000 TB. Similarly, next is exa. Exa is represented as E, which is 10 power 18. Next is the zeta, Z, 10 raised to power 21. And the last one, the unit that we have is iota, represented as Y, 10 power 24. So like these iota bytes and the zeta bytes are typically used as a standard for supercomputers. Typically we use it for supercomputers and the mainframe. Supercomputers are basically they got a storage of iota bytes in fact. So next let's talk about the computer components. So now we have talked about the basic definition of computer. We have discussed fundamental the concept, like what a computer does, what are the basic functionalities, input output. We've talked about basic components of computer, storage devices, and how the data is get processed. Now let's talk about the hardware components. Like in a personal computer, what sort of components you will see in a computer. So most important components of a personal computer is motherboard. The most important component of a computer is motherboard. We'll discuss motherboard, and in our PowerPoint, which I'll show you guys in the class, you will see the motherboard with the slots, which I'm going to discuss here. Motherboard, then we got RAM, random access memory, then we got storage devices, which we have already talked about, storage devices, and last is the firmware, which is of course very important, which defines the structure, how a computer will restart, boot up, and things like that. So let's start with the motherboard. First of all, this is the most important component of a personal computer, motherboard. Motherboard is just like a circuit. You guys will see if you open up your system unit. System unit is like the tower shaped box. If you open it up, you'll see a circuit like a board with having a lot of slots and those things, like a green kind of the programmable computer control board, which is called PCB, and hardware and everything is mounted onto it. So that's called motherboard. So motherboard is also called main board of a computer. And why we call it motherboard? Because all computer components are attached to it, so all computer components are basically attached to it. The motherboard is basically, like, you will see the mesh of circuits, the mesh of the buses or wires onto it, like where the data basically moves from one component to another component. Some of the notable things that I have discussed in the PowerPoint as well, like one of the notable thing is CPU socket. CPU socket is like a small socket where we connect or insert CPU. Connect CPU. That is basically small central processing unit, the brain of the computer. Second is basically Express PCI bus express bus expansion socket or expansion slot. So that's basically where we can slots where we can add additional functionalities to computer, additional features, or let's say you want to add some hardware. For example, let's say graphics card. You want to add graphics card or video card adapters, etc. These kind of things. So we can use with the PCI Express bus expansion. PCI is basically the peripheral controller interconnection express bus. Bus is basically called the wires, in fact. This is, again, if you see the motherboard, you will see those expansion. Other than that, we do have RAM slots, where typically, as name suggests, we connect the RAM. And of course, you can connect the array of RAM, 2 or 3, 4 RAMs, which are interconnected. Then we got a chipset. Chipset is basically a communication module, which allows or control data transfer. It control the data transfer between memory and CPU, or for example the expansion slots. There is another connector as well, which we use for expansion, but those are kind of obsolete now. There is another connector which is called SATA connector. SATA connector is basically to connect SSD hard drive. Okay, like the fast hard drive can be connected with the SATA connector. Another one is the IDE connector, integrated design environment connector, which is for traditional hard drive connection. You will see that on your motherboard as well. Then the last one is the power connector, which is the main power connector for motherboard. Main power connector. And main power connector is basically it's the power supply to motherboard. The power cord is connected to that power supply to motherboard, and then it will distribute to all components attached onto the motherboard. Okay, so this is basically the first part of a typical computer motherboard, and we have discussed what a motherboard is, and different components of motherboard. Now let's talk about the second one, RAM. I think we have already talked about RAM, random access memory, short-term memory, and as I mentioned earlier, what a computer can do, what a PC can do, what a computer can do or what it cannot do, or cannot do is based on your RAM. So RAM defines what a computer can do and what it cannot do. Storage device, we have discussed the storage device. Typically, whenever we talk about storage device, we are talking about the hard drive. Okay. Last thing is the firmware. So let's see what exactly the firmware is. So we have discussed the storage devices, RAMs. Let's talk about firmware. Firmware, as name suggests, firm software. Firm software is basically a software which is installed by the developers. So firmware is basically a computer program, you can call it software as well, program installed by developers of the hardware. Like for example, in your case, if you have a Dell machine or if you have a HP or Apple, so firmware is basically installed by the developer, your the vendor of your hardware. Stored onto ROM. ROM stand for read-only memory. Although we call it memory, because memory, whenever you see this term memory, means something volatile, but read-only memory is something which is not erasable. It's gonna stay there. And this firmware, what exactly the firmware does, it basically tells operating system what to do once power is applied. When, let's say, when you turn on your PC, power is applied to computer. So typically the firmware, they use a process called BIOS, basic input output system, and there is a new one which is called UEFI. That's a new thing. UEFI, it is basically a process like when you turn on your computer, boot up your computer, it goes through a process, and that's called BIOS or UEFI, which is unified extensible firmware interface. Okay, and this is basic input output system. So for example, if you just, let's say this is your PC, you just turn on your PC, it goes through a process called BIOS or UEFI, and that particular instruction is stored onto the firmware. Okay, firmware software, which is stored onto your ROM, installed onto motherboard. So the process of boot process. So for the boot process, I think let's write down here. So boot process, a system goes through 5 steps. There are 5 steps of the boot process. And what is boot process? Boot process, it takes your computer from a turned off position to, for example, fully on. So in the boot process, we got 5 steps. The first step is power is applied to computer, or simply you can say motherboard. So when you turn on the PC, the power will be applied to motherboard. What it's going to do, it will start your CPU. So this is kind of first step in the boot, and these steps are stored onto your ROM, and that's basically the firmware is. CPU will start, and after CPU will start, what CPU is going to do? CPU will initializes BIOS routine. Like for example, it is ready to take input from you, and it will run post power on self test. Power on self test is basically like computer will see if all my hardware, everything is aligned. After power on self test, the next is it's gonna boot other devices of computer, plus it will also search for operating system, like look for operating system where operating system is. Then number 5 is loads operating system onto the RAM, like the small portion will be loaded onto the RAM. And number 6 is operating system starts services. Like for example, whatever the service, let's say if you're running a server or if you're running any sort of thing, it will start that particular service. So these are basically the 4 most important component of a personal computer. Motherboard, we talked about it, all the components, RAM, hard drive, everything is basically attached onto the motherboard. And then we talked about RAM. We have already discussed RAM, storage device, and the last one was the firmware. Now let's move on to our second last agenda item, sorry about that. One is the characteristic of bus. What exactly the bus is. Like if you, I'll show you in the PowerPoint, you will see that in the motherboard, you will see those small lines like a wire. Those lines are basically called bus. So what is a bus? Bus is basically the collection, or you can say network of collection of wires carrying data, carrying, or you can say move the data, carrying data from one place of a computer, one component, that's the right term, one component to other component of computer, component of a computer. Of a computer. And again, bus width is very important because it defines how much data can be passed through the bus. Okay, and these buses connect one device with other device, and whenever any data gets into the computer, it goes through the motherboard. Buses can be, the buses are from CPU to RAM, CPU to expansion slots. So for example, if you input anything, so CPU can directly access that. CPU to input output devices, IO devices. It's these are also from CPU to hard drive, etc, etc. So these buses basically connect all the components to CPU and with each other as well. Like it's an internal network, like where, let's say you got, for example, RAM. So RAM is connected with, for example, CPU. CPU is also connected with, for, let's say, input output devices. CPU is also connected, let's say, hard drive, for example, ROM, etc, etc. So that's basically, everything is basically mapped onto the motherboard. So the last agenda item is the network communication model. I'm going to give you a quick overview of the network model, and then we will discuss the network in detail in the next class. So as we have already talked about what a network is a group of computer, or you can say collection of computers connected together. Computers connected together using transmission media. So this transmission media can be a wired one, or it could be, for example, maybe a wireless as well. Okay, and again, why we create a network? So devices can exchange information, or for example, computers can share the resources. No, network can be of three types, and again, we will discuss that in detail. But I'm just gonna give you, just for the definition purpose, I'm gonna give you this idea. So network can be a small network, for example, intranet, also called LAN. LAN stands for local area network. We will discuss that in the next class, but I just want to give you a small heads up definition. Local area network. So for example, at your home, you guys have a small network. This is, let's say, your access point, router access point, and all the devices are connected with your access point. Let's say this is a laptop, cell phone. So you have a small network at your home, or let's say in the building. Let's say this is our GGC building. We got a server, devices are connected with that. This is called intranet. So intranet is local area network where it's basically within the organization. So you can simply say group of computers connected together within organization. That is called local area network. It allows users to access resources or communicate with each other within organization, like within the local area network. That's the intranet. Now, for example, if GGC got two buildings, let's say we have one building here at Lawrenceville, and let's say I do have another building in another city. Let's say, for example, sorry about that, I have a building here. This is Lawrenceville campus, and let's say we got another building maybe in Atlanta downtown campus. So if you want to connect these two, let's say New York, for example. So if you connect these two networks with each other, you want to connect these two networks with each other, one of the possibilities is we can lay down the fiber or coaxial cable or something like that, which is not convenient. So we can connect them by using a public switch telephone network, like for example, a ISP. We can connect them together. That's called extranet. So extranet is basically also called wide area network. We will discuss that in detail in the next part. Extranet connects two or more local area networks using public network. And that public network is basically ISPs or internet, you can simply say. And it allows certain organizations and businesses to access each other's resources, each other resources outside the local area network as well. And now what is internet? And that's a big form of internet. Internet is basically network of interconnected computer network. Let's say if you connect all the externet across the globe, that will basically what internet is. Network of interconnected computer networks. That is basically what internet is. Let's say all the extranets across the globe will form an internet. Okay. Now, in order to design a network, what sort of resources or components that we need to have? If you have a computer, you want to put it on a network. So what kind of resources we need? We need 6 components. So network components are basically components that turn a standalone device, a standalone computer into network computer, into a part of the network, networked computer is called computer components. So what sort of resources or components that we need in order to design a network, in order to design a network? First of all, we need a network interface card, NIC. It's called network interface card. So network interface card, and what it does, let's say this is your motherboard. In your motherboard, you got expansion slots. In those expansion slots, you need to put a card, and that is network interface card. So it connects your computer. Let's say this is your PC, and this is your PC's motherboard. On the motherboard, we will plug in this NIC. This is NIC. So plugged onto motherboard, and it will plugged in onto motherboard, and it provides connection to the network, or it connects that computer to the network, provide connection to the network. After that, what we need to do, we need to let's say this is your, for example, motherboard, and you have this network interface card. We need to connect with a medium like a cable, or for example Wi-Fi, any kind of medium, Wi-Fi, with the access point, which could be switch, or it could be, for example, maybe a hub, or it could be router as well, and it will be connected with other devices as well. There would be other devices connected with that. So network medium is basically a cable that, or Wi-Fi, for example, technology that connects the computer with networking device. Let's put it that way, with network or networking device. Now, the interconnecting device is basically, it could be interconnecting device. This is interconnecting device. It could be a switch, or it could be, for example, hub or router as well. Okay, this interconnecting device connects devices within local area network. So devices can be connected within local area network. So they're not directly connected with each other. So connect devices with local area network. Even devices are not directly connected. So even devices like computers are not directly connected, but still can communicate with each other. communicate via these communicate via these switch or interconnecting devices. Connecting device, which I told you guys can be a switch or can be a hub. Okay. So we got NIC, network interface card. We got the network medium, which is a cable, Wi-Fi. We got interconnecting devices. Next, we need a software as well, which come with your computer services in fact, and those services are, for example, the BIOS and stuff like that. So network software, there are two type of network software: network client software, network server software. We will discuss the type of network in a bit, like peer-to-peer and client server model, in the next class. So network client software, what is a network client software? Like, for example, client computer is basically which requests for resources from other computers, or typically from the server on the network. And client software, what it does, it basically allows the clients to request for information, or for example, if they need any kind of resource. Network server software, what basically server is, which basically facilitate the clients. So servers facilitates clients, facilitate the clients. So network server software, what it does, network server software allows computers to share resources. So these are basically few services which by default come with your operating system. We will see that in our class today. Next is the protocols. We will discuss TCP/IP protocol and OSI model, and then you will get a basic idea about the protocol. Beside all these things, we also need rules, and these protocols define rules and formats. Like, for example, if you want to upload or download data, there is a protocol called FTP. If you want to just visit the page or access it, HTTP, hypertext transfer protocol. If you want to send email, we got a protocol, SMTP, etc., etc. So define rule and format. Each computer has to follow. Each computer has to follow to send or receive information over the network. Last is we need the NSC drivers, network interface card drivers, in order to empower the network interface cards. So what they do, they receive data from protocols, like whatever the sort of data is, protocols, and then forward it to physical NIC. So basically these device driver, they convert into 0101 and those kind of fine. So that's it about today. So we have discussed the network components, like different parts, how we can design a network, what sort of resources we need in order to build a network. 6 components that we have discussed today. And then we have also discussed the basics of we have talked about the basic components of computers, their functionalities, etc., etc. If you will have any question, please bring it up in the class. Thank you.